Hello, I'm Seema and welcome to part 38 of the chapter Organic Chemistry, Some Basic Principles and Techniques. Let us now start studying about qualitative analysis of organic compounds. In the laboratory, you have been doing the salt analysis, where a salt is an ionic compound. It is made up of a cation and an anion, and when you analyze the cation and the anion, you can tell what salt it is. Similarly, if you are given a powder of an organic compound, a powder or the solid form or a liquid of an organic compound, and you are expected to find out what that organic compound is, what would the steps be? It wouldn't be as simple as an ionic compound because first of all, organic compounds are basically covalent in nature. They are not ionic in nature. Secondly, organic compounds, a separate branch of chemistry has been given to organic compounds, and the reason being that they are so vast in number. And if you know, let us say, the functional group of a compound, all the compounds that have the same functional group fall in the same homologous series. So you're not dealing with just one compound, you're dealing with 1,000 compounds, even more, as you keep increasing the size of the chain. So you don't know how many compounds would come in that category. Then, if instead of one functional group, the compound has multiple functional groups which are the same or different functional groups, the more complex it becomes. Therefore, organic analysis is not as easy. And that's the reason why at your level, that is at the school level, we study it at a very elementary level. It is when students at the PhD level who would really be going into be able to find out a compound from a powder like you do it in the case of salt analysis. But yet, I'll try to explain, on the whole, what the steps would be like, and we'll study a little bit about the qualitative analysis. So you get a compound, and you have no idea what is it. But you are aware that it is covalent in nature, therefore it might be an organic compound. So to confirm that it's an organic compound, we know what are organic compounds mainly. They are hydrocarbons, which means that organic compounds should contain carbon and hydrogen. So the first thing that you would look for in a compound to make sure it's an organic compound would be to detect the elements. You want to detect the presence of carbon and hydrogen to make sure that this compound is an organic compound. So that would be your first step. So what do you do in order to do that? But let me come back to this later. How would we do it? But then first you identify that it has got carbon and hydrogen. Once you've made sure it has got carbon and hydrogen, it means it's an organic compound. Then you would go in for other elements that may be present in the compound. We know many functional groups have other elements, like you have oxygen, you have nitrogen, you have sulfur, you have halogens, you have phosphorus. So there are other tests that help you detect the other elements. The other elements like the presence of nitrogen, sulfur, halogens, and phosphorus. In order to identify the presence of nitrogen, sulfur, and halogens, we prepare a special extract which is known as the sodium extract, right? It is the sodium fusion extract. And this was done by a scientist called Lessans. Therefore, this is known as the Lessans test or the Lessans extract. What do we do in preparation of Lessans extract is that all covalent reactions are basically slower. And we want a reaction, on the other hand, ionic reactions are fast and they are easily identifiable. Therefore, we try to convert these organic compounds, especially those compounds containing these elements, into their ionic forms, so that now you get a test that is quicker. For that, you prepare a Lessans extract with the help of sodium. You fuse the compound with sodium, and if it has nitrogen, sulfur, or halogens, it would result in the formation of cyanide. In the case of nitrogen, because the sodium cyanide, because we fuse it with sodium, so you get the ionic form of these elements. So you'll get sodium cyanide, you'll get sodium sulfide, which has sulfur, or sodium halide. All of these are ionic, and then you will carry out the ionic tests to identify the presence of nitrogen, sulfur, and halogen. And then there is another test for phosphorus. Now you have identified the elements. You are aware that the compound has got whatever element it was, an organic compound, by detecting carbon and hydrogen in it. Then you identified the other elements. So now you have a fair idea that this is a compound which is organic in nature, which is covalent in nature, and it may consist of these elements. So what would your next step be? Your next step would be to find out the percentage composition of these compounds. But before that, what would you do? You would like to find out the functional group that is present. Let us say that there is any of these elements present. You would like to find out what is the functional group, or even if it is just carbon and hydrogen, you would want to know whether the compound is saturated or unsaturated. So you will test it for the presence of a functional group, for saturation, unsaturation, and there are distinct tests for functional groups. These you do in class 12. You do a little bit of organic analysis. Once you know the functional group also, you know the elements which are present, the atoms of which elements are present, you know the functional group that is present, and now you find out the percentage composition of the compounds. You take a certain mass and you find out, and in this mass, what is the mass of carbon, what is the mass of this element, what is the mass of that element, and if this was the whole that we took, what was the percentage of each element. So you now know the percentage composition. From percentage composition, what do? If you, by mass spectrometry or by some other method, if you are able to find out the molecular mass, now you create an empirical formula. Since you know the functional group, you will put the functional group there and the rest of the atoms, and you will make the empirical formula according to the ratio, the mass percentages of each element. And then from the empirical formula and by the knowledge of the molecular formula, you can now divide the molecular formula by the empirical formula, and you would the masses, and you would know how, with what number are you supposed to multiply the empirical formula to get the molecular formula. So if you know the molecular mass and the empirical formula mass, then you can identify the compound. Now this step is pretty complicated, and that is why you don't do it at the school stage, but you have a fair idea of how it is, what are the steps, and how would you go about it. It's a long process, it involves different techniques, and we are going to study the basics here. So the first thing that you do in qualitative analysis, so what are we doing? Qualitative means what is present in it. But we cannot find the compound just by knowing the elements. After this, you have to go in for the quantitative analysis, where you find out the mass percentages. That is quantitative analysis. You're finding out the quantity of the substance. And then you go further into analysis, where you want, by mass spectrometry, you find out the molecular mass of the compound and the empirical formula masses, and that is how you would go about finding the compound. So in qualitative analysis of organic compounds, we first detect the presence of elements carbon and hydrogen, because we are talking of organic compounds. How do you test the presence of carbon? If you react carbon with copper oxide and you heat it in the presence of copper, along with copper oxide, it releases copper and carbon dioxide is formed. Carbon dioxide which is produced would be a gas, you're aware of it. And we know how to identify carbon dioxide. If you pass carbon dioxide through lime water, the carbon dioxide reacts with lime water and turns the lime water turns turbid. It becomes milky. And the presence of that the expression of that milky color, or when it appears, you know that carbon dioxide was produced. If carbon dioxide was produced, obviously carbon was there. So when carbon reacts with cupric oxide, you get copper and carbon dioxide. Similarly, when hydrogen reacts with copper oxide, what do you get? What do you get on heating? In other words, you are heating the compound with copper oxide, and what you get is copper and carbon dioxide. And if hydrogen reacts, again you get copper, and hydrogen combines with oxygen to produce water. So you get water. Now how will you identify the presence of water? So the carbon dioxide which is produced, that can be identified by its presence can be identified by passing it through lime water. So you see here, lime water is calcium hydroxide, And when you pass the carbon dioxide through lime water, it results in the formation of calcium carbonate, which is a white precipitate. And the lime water turns milky, and you can identify the presence of carbon in the compound. And water is produced. And the water that was produced here, that is also collected separately, and it is passed through or it is added to anhydrous copper sulfate. Anhydrous copper sulfate is white in color, but if you add water to it, it becomes hydrated. And the hydrated form, in the hydrated form of copper sulfate, there are 5 molecules of water of crystallization. So copper sulfate anhydrous, which was white in color, when it becomes hydrated crystals, that is copper sulfate 5H2O, it turns blue in color. So the color turns blue, which proves the presence of water. And the presence of water proves the presence of hydrogen, right? So this is how we find out that carbon and hydrogen are present in the compound. Now let us see what happens in the apparatus. This is a combustion tube. The combustion tube consists of, this is an outlet or rather an inlet for oxygen. Pure dry oxygen is entered here so that you're not adding any moisture, because you are identifying hydrogen and carbon. So if it was moist air, it would add the hydrogen which you don't want. So you will add dry oxygen to this so that the composition of the compound does not change and hydrogen and carbon can be detected. If hydrogen and carbon are present, then these pellets are of calcium oxide. Sorry, not calcium oxide, copper oxide. These pellets are of copper oxide. So they pass through the copper oxide pellets, and as they pass through the copper oxide pellets, what is produced? Copper and carbon dioxide, copper and water. And now our aim is to separate the carbon dioxide and water before we carry out these next 2 tests. So what do? We have a U-tube here in which there is anhydrous calcium chloride. The anhydrous calcium chloride will absorb the moisture. Anhydrous calcium chloride is a desiccant. It is supposed to absorb the moisture. So if water is produced, the water would be absorbed on the anhydrous calcium chloride, and as the gases pass through these pellets of anhydrous calcium chloride, when it comes here, it is dry. There is no more water in it. And we allow it to pass through a second U-tube, and this U-tube consists of potassium hydroxide solution. Potassium hydroxide dissolves the carbon dioxide that is present. So what have you done by this apparatus? You have separated the water produced and the carbon dioxide produced as a result of the reaction with copper oxide. After you get the water from anhydrous calcium chloride, now you will heat up the calcium chloride and the vapors will rise. You will condense them and you will get that water. And you will add that water to copper sulfate solution and you will get copper sulfate pentahydrate, which would turn blue. So this tube, the extract of this tube is going to prove the presence of hydrogen. And KOH solution, you will extract the carbon dioxide gas from this and you'll pass it through lime water. When you do, the lime water will turn white or it will turn milky, which will prove the presence of carbon dioxide, which in turn will prove the presence of carbon. So this is how we come to know we detect the presence of carbon and hydrogen in the compound, which is the first step. After this step comes the second step, where we want to identify other elements. So detection of other elements. What other elements can we detect? Nitrogen, sulfur, halogens and phosphorus. In order to detect nitrogen, sulfur and halogens, we prepare the Lessen's extract. So in this video, I'm only going to tell you about the preparation of Lessen's extract, and from the next video onwards, we'll be studying the tests for nitrogen, sulfur, halogens and phosphorus. So how is the Lessen's extract prepared? The elements present in covalent form in the compound are converted into ionic form. I told you that the compound consists of all these elements. When they are present in the organic compound, they are covalently bound. But covalent reactions are slow. So we first convert these covalent compounds into ionic compounds. And how do we do it? We do it by making it react with sodium. Why sodium? Because sodium is one of the most reactive elements. It is one of the most reactive metals. Since we are talking of covalent compounds, all of these are far more electronegative in comparison to sodium. So when they react with sodium, they'll result in the formation of an ionic compound where sodium will be the positive ion and the other part, that is nitrogen, sulfur, halogens, they would form a part or would form the negative ion. So what happens? The compound is converted into its ionic form so that the reactions are faster and clearer for us. So they are converted into the ionic form by fusing it with sodium metal to form the sodium fusion extract. When you go to the laboratory, if you're in class 12, you will be given these little fusion tubes. They are very little test tubes, really small. And you hold it with the help of tongs and you add your salt into it and a little tiny piece of sodium. So the sodium is added to it and the salt, and it's heated over a flame. The sodium immediately kind of catches fire, and that is when the salt and the sodium, they start fusing together due to that combustion process. And then you immediately plunge it into cold water, a beaker containing cold water or a water trough containing cold water. When you put the red hot tube of sodium and this compound into the water trough, that immediately bursts. And when it bursts, the extract that the sodium and the compound, the way they reacted in the ionic form, that ionic compound goes into the water. So it is converted into ionic form by fusing it with sodium metal to form a sodium fusion extract. This extract is also known as the Lessen's extract. Now, how does this happen? If you put sodium and the compound, of course, since it is an organic compound, we already know it contains carbon. And if it has nitrogen, it will result in the formation of a cyanide. Sodium cyanide will be formed. If sulfur is present in the compound, you will get sodium sulfide. If on fusion with sodium, any halogen is present, the halogen can be chlorine, bromine, and iodine, it will result in the formation of the sodium halide, that is sodium chloride, sodium bromide, or sodium iodide. Now, the cyanide, sulfide, and halide of sodium so formed by the fusion are extracted from the fused mass by boiling it with distilled water. So now that water that you get, you will extract the compound from it and you will start boiling it. In the trough, what you will be taking would be distilled water. You will not be taking tap water, because if you take tap water and the tap water contains any of these minerals, then you will get wrong tests. Even if you did not get the fused mass, the sodium compound of it, you will still get the result of those tests. You don't want that. So you will do this with distilled water. So you will extract it from the fused mass by boiling it with distilled water. This cold water that you plunged it into and the fusion tube bursted and the compound got dissolved, you will filter it out, you will boil it, and now what you get is your sodium extract. And this is used to test for sodium, sulfur, and halogens. And that is what we are going to be doing in the next video. So with this, I'll wind up today's video. If you found it helpful, please give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.